channel got it set to a start time of 8:30, so YouTube's interface for setting up videos like this is a little bit, it doesn't work well with the browser, so I get little errors like that, and I decided to just kind of roll with it. That gave me some extra time to prep. Things have been pretty busy here because of digital atmosphere. And you can see the manual I'm working on here in Adobe Illustrator or Adobe CS4 here. So it's gradually starting to come together, but it is a lot of work, and that has to be paired with the work in the compiler. So anyway, that's been keeping me pretty busy. Weather-wise, the Canton tornado out in East Texas was upgraded to EF4, and that makes it the second EF4 of the season, and I believe the first one was on February 28th in Missouri. There was one reported there, but you can see two relatively long track tornadoes here, and Dallas is over here on the left side of the screen, so this is about maybe 40 miles away. And just a quick look at the radar for anybody who missed the presentation a few days ago. This is what the storm looked like, and it's almost very deceptive. It looks a lot like these other storms further to the west. And if you're going strictly by radar, you don't really see the classic supercell shape, a little bit of a diamond or triangle appearance, but we roll that forward, and you know, if this was the 1980s on the old WSR-57, it would be hard to justify putting a warning out. You'd be really depending on those spotters. But thanks to Doppler radar, this is really a great example of how valuable this is. We can see the circulations going on in that cell. And the west tornado that produced the EF4, this is over here. It took this track, and then this other one further to the south, this generated the eastern track. So if I roll this back, you can see how they're kind of paired up. This one kind of taking this track, and then the other one down here near Eustis, moving north like that. This is starting to get just out of range of the radar. You can see here, in fact, when this storm is producing a lot of the damage in Canton, we'll roll that forward. You can see that we lose some of the distinguishing characteristics of the circulation there. And the radar beam is up at an altitude of about 7,000, and that's getting pretty high up in the storm cloud. And we're talking about 72 miles away from the radar. And 60 is really about the practical limit of tornado detection. So we really could use a radar out in East Texas. That's one of the remaining gaps where there's high population and poor radar coverage. In fact, I think out near Crockett, Texas, they're about 80 or 90 miles away from any radar, so kind of a bad situation there. Okay, back to the weather, and we'll just kind of shift gears into today's weather. Kind of quiet, but a slight risk in northwest Oklahoma and the northeast panhandle. We can see a little bit of the picture here in digital atmosphere. Very warm air mass down in Texas, and we can see that the moisture is slow to come northward. If we draw the 60-degree isodrosotherm, that's well to the south. And then the 55 line, well, some of that's all the way up to Oklahoma, the rest of it kind of like that there. Okay, so that's the 55 isodrosotherm. So we're in a return flow pattern, but kind of early in that phase. So we got a warm front kind of set up like that. North of that, we've got flow up from the Canadian area, maybe the Great Lakes. And very clear cyclogenesis out to the west right there. So a combination of lee side troughing here and baroclinic development taking place out there in the panhandles. And we've got a low right there near Boys Ranch to Dalhart. And this is that old territory where they used to have a massive ranch about 100 years ago. And the name escapes me, but it was like the Bar X Ranch or something like that. One of the largest ranches ever in history, and that's the territory where that is now. Okay, let's switch over to SPC and look at some of their products. And we'll take a look at their Texas sector here. So the wind plot and isobars looking like this. We can see the inverted trough across Oklahoma, signifying the warm front there. And we've got elevated convection out over southeast Colorado and the adjoining states right there. Now, you can see some of this is north of the warm front, and some of this activity here is clearly convective. So which Cape measure should we use? Well, we've got surface-based. We can't use that because there's no parcels down here being ingested into these storms. The parcels near the surface are negatively buoyant. So mixed layer, no, that's only going to consider the lower layers. So that consists of a lot of negatively buoyant air. I can click on it and we can see what it comes up with. But you can see that we've got pretty much no values here. Most of the good mixed layer values are along and south of the front. So what we would have to use up here is most unstable Cape. And that's what would really capture some of the elevated instability in that area. And you can see values here around 250, very modest. And then we pick up about 500 right there. So on a day like today, most unstable is probably what you would want to go with to isolate the best instability. Okay, let's take a look at the upper air charts, and I'm going to start using the SPC charts because they cover areas further south, and that's what we need to be looking at this time of year. We can see a long wave trough across the central U.S., and embedded in that looks like we've got a pretty good short wavelength trough across the southwest U.S., and west of that we've got northwesterly flow, kind of unusual for this time of year. 500 millibar chart. This particular panel here doesn't show the waves too well. Only the larger ones, like the one here in Arizona and the Four Corners. The very small short waves, those are going to be kind of hard to pick out on this chart. We have to have the help of the dynamics diagnostics like the vorticity chart to kind of find those waves. But anyway, you can see big vortex across the Great Lakes and polar front jet from the Central Plains into the Ohio Valley and up to New England, right like that. And looks like a new segment coming in here from the Pacific Northwest. And then we see a little bit of a stronger flow down here. 500 millibars is probably a little bit on the low side for that to be a subtropical jet, but we'll take a look anyway. And I think we probably do have a little bit of subtropical jet action. Down in Florida where Ryan is, we've got 65 knots right there at Key West. So we're probably picking up a little bit of a polar front jet, and we're seeing a little bit of coupling with the polar front jet in this area right here. And then in 850 millibars, this is where we look for the moisture. And values are on the low side. At 850 millibars, we have dew points right around 30 to 35 degrees Fahrenheit in Texas. So the better moisture looks like south of Brownsville even. Brownsville reporting a dew point there at 850 millibars, also in the 30s. And only when we get to Monterey, Old Mexico, we start to pick up values in the 40s. So the moisture is, the deeper moisture is pretty well to the south. But we do have the return flow starting up, and we have 25 knots right there at Brownsville. Satellite is looking like this, pretty quiet, but we can see a bit of a wave across the Colorado area. And that's probably associated with that trough that we have across the Four Corners this morning. The isobars and thickness chart looking like that. Most of the low pressure is found in New Mexico right now. And there's that inverted trough across Oklahoma. And we can see a bit of a pressure gradient, or a thickness gradient, to the north of there, covering much of the Central Plains. So that supports a warm front through this area and extending all the way into the Utah and Nevada area. So a big baroclinic boundary going all the way to California here. And that's a lot of contrast for that upper level wave to work with as it moves eastward. And we'll take a look at a sounding. We'll look at Fort Worth here. So what we're looking at here is what the sounding tells us. At first glance here, I see things are fairly dry. Looks like the moisture has come up a little bit from this morning. We're now seeing values in the 50s. So it looks like we've managed to pull a little bit of moisture northward, priming things, and the depth of that moisture just under, just up to the 850 millibar level there. Not much capping at this time. But as the flow picks up, likely we'll see that start to increase a little bit. And let's take a look out to the west at Midland. This is very characteristic of air behind the dry line. You can see it's pretty much dry adiabatic all the way from the surface up to about 14,000 feet. So this is telling us surface temperatures are in the mid-80s there. And if we lift a parcel on that, well, there's not much moisture to work with, so our LCL is up pretty high, close to about 15,000 feet. And then our parcel lift is on the negative buoyancy side of the environmental trace here. So this is not really good for thunderstorm activity, but often in soundings like this in the middle of summer in places like Denver and Cheyenne, they manage to indeed pick up a couple of high-based thunderstorms there. And all it takes is a little bit of cold air in the column like that right there. So if you try to lift in that, your parcel gets into this cape area. You end up with maybe 500 to 1,000 cape, but the storms are high-based, and this is what we call an inverted V profile. And the main threat of severe weather, if we do get high cape and a sounding like that, is going to be wind. But occasionally they do get landspouts there in Colorado, and on rare occasion hail. Okay, let's look at the dynamics here. Okay, so the panel for right now is going to be right there. So we can see that there is a trough across the Four Corners area. A couple of even smaller waves working through the flow, maybe one there, another one here, and another one over the Utah area. And the stronger flow in this area right here. Okay, so nothing affecting Texas just yet, but we do see a couple of waves upstream from the panhandles all the way back into the Rockies. So things should actually start destabilizing here gradually over the next day or so. It does look like a lot of the lift is focused north of I-40 here. And we're on the other side of the jet here in Texas. So the jet is kind of running like that. So I think we may see a period here overnight of maybe cap strengthening. Combination of advection from the plateau region and being on the south side of the jet would kind of support that. And then it looks like finally later tomorrow the main wave approaches. So we get upper level lift finally ahead of that. You can see that the flow is now cyclonic, whereas earlier in the day you can see it was kind of anticyclonic there overnight. So during the day we will see things start to destabilize as this wave comes in. Very meridional pattern here with this jet diving south along the Rockies. And that could kick some cold air southward. Yeah, that's a very good pattern for bringing Canadian air southward. So we're talking about Friday into the weekend there. And we get a closed low right there over the Tennessee area, and this will probably allow for some severe weather across Louisiana, Mississippi, Alabama, and Georgia. Then big ridge moves in, and that should warm things up and give us a period of not much weather. Okay, since we have a front coming into Texas, this is probably a good time to use the mesoscale models. The high-resolution rapid refresh model probably doesn't go far enough into tomorrow. Got the browser misbehaving here. Okay, there we go. So let me bring up the 3-kilometer NAM here. And this is a convective model. And this will show us the cold front moving southward during the day. Let me bring, yeah, there we go. Let me get that fixed so you can see the time. Okay, so overnight, this is about midnight right here, and you can see we've got a southerly gradient across Texas. Cold front is located roughly along that line. Lots of elevated convection from Wichita back to Pratt and Guyman, Perryton. So not much risk of severe weather there, but it will be tapping inflow from the south here. Probably we'll have a low-level jet set up overnight. Okay, and this is dawn here. And then 9 in the morning. So our front is looking something like that right there at the surface. Looks like a low pressure around the Durant area. And the NAM model decides to fire an MCS north of Dallas. And I can't really argue with that. 21 hours, that's kind of beyond my range to really forecast initiation. So I would go with that and maybe look at other models to kind of fine-tune that forecast. And then we start to get into the phase of heating during the day, which destabilizes things. So we see an MCS moving southward along the leading edge of that front. And this is where the front itself is. The MCS kind of bowing out ahead of that front. And there's probably going to be a risk for severe weather. And that's going to depend strongly on the wind flow, because all it takes is a little bit of a mesolow embedded in this MCS. That looks like maybe a low right there being indicated by the models. And you would have flow a little bit more veered in this area right here relative to the low, and a little bit more backed on the other side of the low. So that right there can really define where your severe weather positions are. If that really bears that out and there's actually a mesolow there, then we would be looking at this area right here for having the best chance of severe weather. So I don't know if the showings are sounding that very, if the soundings are showing that very well, but let me drop a sounding right here around the College Station area. That's going to be kind of southwest of that low. And let me see what it looks like there. And we're going to pay attention to the shape of the photograph. So we see here a tiny bit of curvature. Okay, so let's go on the other side of the low. We'll go out to Nacogdoches, located right here. I don't know if you can see the cursor. Okay, we'll drop a sounding right there. And we'll look at the photograph. And yeah, you can see drastically more curvature there. And what's really important is to actually look at that photograph and think of what ingredients would help lengthen and curve that photograph. Okay, we can see that to do that, some backing of the low-level flow would help, like shifting this dot further this way. So a dot over here would really increase the storm relativisticity, and also bringing the dot this way. Remember, the closer you are to this area here, the lighter the surface winds. So yeah, lighter winds at the surface, easterly winds, that can really dramatically boost your storm relativisticity. And the actual helicity here is being painted out by the storm motion vector right there, all the way to the 0 dot. This is 0 kilometers. And then I usually go to the 1 kilometer level, and that's right here. So the geometric area swept out in that little triangle, that corresponds to your storm relativisticity. So as you look at these photographs, you kind of want to use that to visualize your helicity quantities. So storm motion also has an effect, and if the storms slow down, on a day like tomorrow, that would probably decrease your storm relativisticity. Let's say that that's the storm relativisticity dot, or I'm sorry, the storm motion dot. We would sweep out an area like that. So that's a little bit lower. So we need the storms to be going a little bit faster into the east to really tap that corkscrewing present in the atmosphere. Okay, so just to kind of summarize, it looks like East Texas in this area possibly having the best chance of severe weather. But as the afternoon draws closer, we would want to look more at mesoscale models at maybe different runs, like the Nissel. Let me see if I can show that to you. Yeah, there's a Nissel ARW WRF, and then there's a couple of other options, so you can compare those. And let's see what happens to the MCS later during the day. Just kind of forms up into a big squall line all the way from San Antonio to Tupelo, Mississippi. And there it goes. Then high pressure moves in, and cooler, milder air, and things should go quiet for a while there. Okay, so let's look at the forecast here, and now we'll switch over to the spectral model. Okay, so there's right now. By the time we do the webcast tomorrow night, we'll have storms probably in East Texas, like I showed you earlier, and you can see synoptic low over Arkansas, cold front all the way to the Texas coast, and warm front up in Kentucky and adjoining areas of Illinois and Missouri. So maybe a little bit of that is tapping the southerly flow, and so we'll have a chance for probably some severe weather in northeast Arkansas. Let me go back to that model and take a look at that area. That's the thing about doing these webcasts. It's so hard to keep track of the forecast in different areas because there's so many places to look at. But all we can do is try our best here. Okay, yeah, the 3-kilometer NAM here, it's basically got the MCS outrunning the front right here. And you can see by tomorrow evening when we do the webcast, it's going to be like that. So maybe the better southerly flow will be working on Mississippi. So maybe a few severe cells in that area. But that MCS is definitely in a hurry southward, and then after that we get into the nighttime hours, and unless we have a good source of support, then things would tend to die down a bit. Okay, so going on into the next day, for Thursday, at webcast time, we'll have a low in the Louisville area of Kentucky. Looks like the main baroclinic low will be in the South Carolina area, so more of a triple point, I would say. And then northward we have an occlusion. So probably a lot of the better moisture is going to be well to the south on Thursday. And you can see some strong cold air advection in the wake of that low. There's our 546 line right here. And that's kind of a cold pool there. Maybe a little bit of cold core convection right there around St. Louis and Carbondale. Okay, then for Friday, things sweep northeastward. This is Friday evening, and we just got a big occluded low spinning over Lake Erie and Lake Ontario. Pretty quiet in the central U.S. We're just under a big ridge, big high over Texas, cool evenings, and the Gulf is not open. Most of the return flow way out here. So we're not tapping that moisture at all. And for Saturday, another quiet day. We're starting to tap the Gulf a little bit. Definitely some good southerly flow across the Central Plains, but it's a dry southerly flow. Things get very dynamic out in California and Nevada. It's like a strong cold front coming through Yuma. Maybe a warm front kind of like that. So yeah, that's a big system coming together there. 540 line all the way down the coast to Monterey and almost to Vandenberg. Then for Sunday, the low is now working its way through the Rockies. So there's the low. Cold front going through Arizona there. Warm front up to the north. And southerly flow starting to tap Texas and the Gulf right here. low-level jet getting started up. So we're now starting to look at maybe the dry line becoming active Sunday going into Monday. And there's Monday, maybe a active dry line around Amarillo. There's the southerly flow off the Gulf, and we do have the system in the Rockies very slow to come out of there, and part of that is due to the very meridional pattern. So the polar front jet is kind of like a big wave like that, and the surface systems are getting caught in this river from south to north, and they're going north into Wyoming and Montana. So it'll be kind of a slow process, and Texas will just be getting closer and closer to the moisture, some upslope flow, maybe some chase opportunities there on the high plains. Dry line active around the 10th and 11th. And let's see, I'm trying to figure out what happened to that system. I can see the cold pool across the Four Corners area. I think at this point there's probably just kind of a cold front like that. I think there's been some frontalysis in this area around the 10th or 11th. Anyway, let's see here. Moving forward. '12th and 13th, a couple of systems, weak systems moving through Texas. Looks like a lot of mesoscale type action. And now we're starting to pick up the synoptic scale low right here. This is around the 12th. And that moves off into the southeast U.S. There it goes. And another quiet period coming up for the 13th and 14th. So if you're chasing, it looks like it's going to be around the 8th through the 11th when things are active, and then things calming down a little bit after that. So high pressure after that, and then southerly flow again for the 18th. Okay, I think that's all I got there. Let me take a look at the chat. Sorry, I've got kind of caught up in all the maps and I forgot to look at that. Let's see here. Andrew and Sue M are here. Sue mentioning 4 inches of rain last weekend there in Indiana. Up to 9 inches south of there. I guess that would be near Louisville. Eddie W checked in, and Ryan and Michael. Alexi, Dorothy Tornado. Ryan mentioning the program issues. Ryan, if you know of any digital atmosphere problems you're dealing with, just send me an email, and I'll try to make a note to take a look at that. 80 degrees in Canyon Lake, where Ancient Astronaut is, and let's see, I'm going to have to kind of skip through this because chat is very busy. But let's see here. Tornado simulations. Mick there says, check out Lay Orf videos on supercell tornado simulations. Yeah, I'll have to take a look at that. It's the first I've heard of it. Sounds pretty interesting there. And let's see here. Brett Dean mentioning Weather Brains with James Spann. I remember James Spann, he used to do weather in on KDFW in Dallas back in the 80s and 90s. He went up to head-to-head with Harold Taft and Troy Dungan there. So we had some good talent there in Dallas in the 80s and early 90s for a while. So Weather Brains, yeah, I'm going to have to check that out. And Megan John asks, do I ever use temperature and winds to find the true location of the jet at 200, 250, 300 millibars to analyze divergence? Do I use temperature and winds to analyze divergence. It's pretty difficult to analyze divergence strictly by the 250 millibar charts. Let me bring that up real quick. The problem is that downstream from jet maxes, you do tend to get diffluence. You've probably heard this term where you get kind of like spreading of the pattern. The problem is that's often offset by speed convergence. So even though you're kind of removing mass due to the diffluence, you're actually pushing mass together with the speed convergence, where you have like, it's almost like traffic on the freeway stopping and piling up ahead of these cars here. So you actually add to the mass, and the only really good way to analyze flow like that is with diagnostics, and that means going back to the models or back to the computers and doing diagnostics that way. And you can do that. Digital atmosphere, there's a wind divergence right here. It's kind of off the screen. So it can be done. But a lot of times I will just kind of use some of the model fields and look for, there's the vertical velocity fields that'll kind of fill you in a little bit where that mass divergence aloft is actually taking place. And vorticity, that's another diagnostic you can use, and that'll kind of show you where that mid to upper level ascent is taking place over a area that's coming together. Okay, let's see here. Anything else? I think we're probably done. So anyway, I'm going to go ahead and end for now. And we will have a severe weather day tomorrow. So I'll be keeping an eye on that, and that may upset the start time. We'll just have to see, and I'll try to post something on Twitter and on the live feed page as the day goes on. Anyway, I appreciate you all watching the webcast, and hopefully we will see you all tomorrow. Take care.